acid in water can survive is what? Anybody? The hydronium ions. What's the strongest base in water that can survive? Hydroxide. Because it's stronger like O2 minus oxide, O2 minus let's say, it will react with water and will create OH minus. It will not survive. It will go to OH minus, right? So it's good to know that. Okay, so in this case, what's the answer? 4 what? Let me see your hands. A, B, C, D, E. Okay, great. Anybody has a question about it? No? Yes? Why? Why? Which of the four lines is stronger than... Okay, so here is hydronium ion, right? Correct? Above here are the strong acids. And here below is the weak acid. Here is the perchloric acid, the strongest. All these are strong acids, the strongest hydronium, and then the weak acids below hydronium ions are here. From this scheme, if you remember, you have the answer. Why? Because you know, strong is this, only, strong, only. Only this is strong. All the others are weak. Can you see that? So they're here. Can you see that? Yes? Any yes? Okay.
Why is for number 2, why wouldn't it be C?
Number 2?
Yeah.
Why number 2 is not C? Okay, let's see. Adding more B, that's solid, right? And maintaining the volume of the gas mixture. The question is which one will go to the sheet to the left? Adding more B and maintain the volume of the gas mixture the same. How many people know? How many people want me to say why to answer her question? Let me see your name. How many people want? Why did you ask? So many people don't know. Why you didn't ask? Okay? So it's important. This question is important to know the answer. When you add something to a chemical system that's in equilibrium, it will shift right or left when that which you put participates in the equilibrium constant expression. If it does not participate, in general, because there are some exceptions, will not affect the position of equilibrium. So if it's a solid or liquid that you put in, because it does not participate in the equilibrium constant expression, it's not going to change the position of equilibrium. And for C, you add B, which is a solid. And that solid, that B, which is a solid, does not appear when you write the equilibrium constant expression for this equation, does it? Okay? But that is true. Look, that is true. For sure, only if the volume of the system stays the same. Because if you have gases, and in that case, we have gas, things are not going to be true. That's why I put it on purpose there. Maintain the volumes of the gases mixture the same. Because if I put a lot of B solid, right, and the volume of the gases mixture does not stay the same. It's in a closed container, so I put a lot of solid in. Now the gas does not have a lot of free volume to move around. The volume of the gas is decreased. What will happen in the position of equilibrium? Even though I put solid and does not participate in the equilibrium constant expression, but the volume of the gas now is smaller because it's a fixed container, constant volume, and when I put the solid, the available volume space for the gas now it's less. What will happen to the position of equilibrium? Left or right? Increases the pressure, you have to go lower, and if you have to go lower, which one will go? Right or left? Left. How many people got what I'm saying? Raise your hands. Okay. Pretty good stuff. Yes? Yes? Anybody? Huh?
What's the answer number 3?
For 3? Ready for the rest? Or you want to go home? You had enough for today from those productions. Huh? You had enough? Well, this is an easy one, right? You remember? You know this, look. You know these things, look. pH is equal to minus log of this, right? And the same thing with pOH. No, because of the algebra, right? The higher this is, the lower this is. When this goes up, this, H plus, not the whole thing here, this goes down. Right? And the same thing here. So when the P of something goes up, minus log of something, that something goes down. Right? So when the concentration of hydrogen goes up, pH goes down. The same thing with OH minus, right? That's one thing. In the reader, it's really nice, that diagram. You remember the diagram that has all the pKa's and then all together? There's like a cycle, right? Do you call it or not? Any question for number 5? You got it? What's the answer? How many people say A, B, C, D, E? Yeah. Oh, there you go again. Interesting. Which of the following salts will produce a basic solution which is open water? Basic. You want basic. Okay, sodium chloride comes from what? Comes from HCl and sodium hydroxide. They are both strong, so it's neutral. How about this? Barium hydroxide and hydrochloric acid. Both strong, that's neutral. Yes? Ammonium nitrate, that's from ammonia, that's weak base, and that's strong acid, nitric acid. So that will be what? Acidic. So this is acidic. Strong base, sodium hydroxide, nitrous acid, that's weak. So that's going to be basic. Ammonium chloride, hydrochloric acid, ammonia, weak, that will be acidic. Yes? Now, again, be careful with this because most authors, they make the rule when a salt comes from a strong acid and a weak base, it's going to be acidic. But this rule does not hold true unless you talk about monoprotic acid, monoprotic base. If that salt comes from monoprotic acid, monoprotic base, then that rule is correct. But I have not seen others to really state that, and it's very confusing. So you remember when I give you like sodium sulfide, or an anion that comes not from a monoprotic acid, but from a diprotic acid, like sulfuric acid, phosphoric acid, H2S, then that rule is not working always. Sometimes does, sometimes does not. And to make sure that you find the right answer, you have to do what we did. I dissociate the salt, you see the ions if they react with water, and if they do what they produce, and if they do both ways, then you have to do equilibrium process to decide. That's the whole story, right? Everybody got it? Yes? Okay. So what's the next problem? We're almost done. Any questions with this?